Welcome students. In this lab, we are going to see about the servo motor interfacing with Arduino Uno. A servo motor is a simple DC motor with gear mechanism to increase the torque of the motor and a position sensor to identify the angular position of the shaft. This servo motor is widely used in robotic arm control because of the precise movement and high torque. This is the internal structure of the servo motor. Usually DC motor has a high RPM, but it can't uh, handle much load, like you can't use it for lifting some object. So what they do is they attach a gear mechanism for increasing the torque. So using this gear mechanism, they increase the torque of the motor's output. A simple DC motor is used. In the last lab, you did the interfacing of DC motor. You know that based on the voltage applied to this DC motor, the RPM varies. So the same way here also we are going to use the same principle. The same principle, what the DC motor's working principle is same. Only thing, we add more gear to increase the torque of this motor. Okay, next thing is uh, uh, DC motor runs continuously. It rotates continuously. So the application of a DC motor can be like a wheel, a driver for a robotic car. Okay, it can be used for driving or making the car to move, but it cannot be used directly with for controlling a robotic arm, because for a robotic arm we need a feedback, like what is the position of the arm, so that our program can do the necessary action. Like if I want to move a robotic arm for a 90-degree or 45-degree, I need to have a feedback. What is the position? Based on the position, I have to make the displacement. That is not available in the DC motor. That part is also added over this servo motor. So these circuitries are used to sense the position of a DC motor's angle. Okay, so this servo motor mostly is used for a rotation of one single rotation, but with a high torque and precise angular movement. Okay, it's not going to be like continuous rotation. Uh, it is going to be an angular movement. Uh, that angular movement can be measured through any like some sensors were used, like very basic one is potentiometer. If the potentiometer is controlled or by the rotation, if you use a potentiometer here, this is a potentiometer actually, uh, just like volume control you are doing in your older tape recorder, TV, or there you have a volume control. When you rotate that knob, internal resistance actually changes. Based on the resistance value, the voltage divider, based on the resistance, you can understand the position of the angular displacement. Okay, you will be able to measure the displacement, how much rotation or how much angular it have got tilted. Uh, so that with that basic mechanism, the angular displacement is measured and given back to the control circuit. What is there in this control circuit is this is the functional block diagram of a, servo motor. This DC motor, and the shaft is there, the rotor part. Rotor shaft is connected to a gearbox, and the output is taken here. And this shaft position is measured through the potentiometer, as I said in the previous slide. So the output of this potentiometer will be in voltages, either a rise in voltage or fall in voltage. This voltage I'm comparing with the input voltage for the control. So basically this servo motor will have three leads. Here in this example it is given four, but in our example we are going to take three leads. One is positive, another one is negative for energizing the motor, and another one is the control pin. Okay, control pin, what is the control signal we have to give for the displacement. So the position value I have to give in analog voltage. For example, if I give 0 voltage here, then it will be going to the it is default position. If I give 1 volt, then it will move at 40 degrees right angle. And if I increase the voltage, it will move its angular positions accordingly. So the difference between the position value, this uh, voltage measured from the potentiometer, and the input analog voltage, this voltage difference is measured, and it is applied as the voltage to the DC motor. So the DC motor will uh, will turn on in and rotate right clockwise or anti-clockwise based on the error voltage or error amplified signal. And once the position is reached, the potentiometer voltage, this voltage, and the applied voltage, when this both are equal, the error voltage will become 0. It is like the output voltage of this functional block is like error signal minus input signal. If the error signal is greater than this input signal, it is going to run in the clockwise direction. If it is in the other way, it is going to run in the anti-clockwise direction. So this way you can also control the direction also. So here the error signal based on the when both signals are equal, when the both signal are equal, the error will be 0. At that time the motor will stop. So we can with this, if I increase the voltage, then the error will increase and it will make the motor to rotate, and it will make the shaft to turn. And when the shaft gets into the position, till that point the potential here, this error signal will be there, and when it reaches this error signal and this both are equal, this error detection amplification, this output or the input given to the DC motor will become 0. So it will turn off. This is a basic principle of uh, simple servo motor. The application of this is used for various uh, robotic arm based application. Very simple mechanism with you will have high torque, and precise movement also is achievable. So the first experiment what we are going to do here is, here I have two experiments for you. One is based on controlling with the potentiometer. If and another one is continuous. It is going to turn right clockwise and anti-clockwise for a 180-degree rotation, and it will, when it reaches its maximum, it is going to switch back. These are the two experiments we have. So first one, what is the first one? As I said, here this servo motor has three leads. One is ground, another one is power supply. Here we use 5 volt, and the another signal is the analog input. Okay, I have to give an analog signal here. So how can I generate an analog signal? We have to use PWM. So this PWM signal, we have to give it to the control signal as mentioned over here. This is the analog signal we give. So apart from that, the power supply is given separately, and the analog signal have to be given here in the form of PWM. And so I have made the hardware connections, the code, how to write the code. Or simply I have to write the code to um, just increase the voltage in this pin for a certain duration, and after it reaches the maximum count, I want to decrease the voltage, just like creating a sine wave, or the same LED example, how we generate the, how we varied the brightness of the LEDs. The same way we are going to program this pin. This pin have to be programmed as analog write pin. So the code goes this way. So here in this example, they have used the header file servo.h. In the next example, I will give as it is one, we can control it with the normal PWM, how to control it with the normal PWM. So here in this, the pin number 9 is being used for servo, just creating these variables. And here, this is the library function servo or class. In this, I'm creating a object called servo 9. Okay, this is created, and whenever I use servo 9, this particular pin is going to control that particular servo motor. And here, this is a for initialization, which pin is being configured as input for the control of servo motor. I have to specify here, and then later in the for loop or in the while function, sorry, in the loop function, I have to write two for loops. One is for clockwise, another one is for anti-clockwise. The clockwise goes, initial value is 0, and it have to increment its value for each value of this iteration. I'm sending the same iteration value to the servo motor. Servo this object dot 9. Write is object dot write. Servo underscore 9 dot write is the function used to write some value into this servo motor pin. And the value, if I post this value, the iteration value is given here, so that particular angle displacement it is going to make. And I'm making adding some delay, for these are all mechanical devices, they need some time to respond. And in the another for loop, I'm just decrementing from the 180 degree to 0 degree. I'm turning it in the anti-clockwise direction. So I'm simply reducing the iteration value or the position value, so that it's step by step it switches back down. Have I introduced you this breakpoints in any early class? So breakpoints, you are aware of breakpoints?
Yes, sir.
Okay, then very good. So you can see that it is moving by step for each iteration. Um, that's all with this first experiment. The second one is, I just want to control this servo motor's position with the help of a potentiometer. I just want to generate an analog signal and give it to the Arduino. The Arduino will convert that analog into a digital and generate an analog signal again. Actually, we can do it directly. We can control this by connecting this potentiometer to this particular pin, but I want to do it through demonstrate it through uh, Arduino. So I add it here. So the analog input is given to the Arduino, and Arduino converts it into digital, and based on that digital value, it generates a particular analog voltage in the pin number 9. Same way, here this LED is also to indicate the voltage. If the voltage is high, it is going to have a high intensity. If the voltage is less, it is going to glow dim. So if I change the uh, potentiometer value, the analog value varies, and the corresponding digital, analog PWM generated in this also varies. So the difference between the position and this input signal, until it get matches, the DC motor rotates, and when it get matches, it stops. So this can be used for uh, robotic arm control. And here, this I have used the same code what we have used for the LED brightness control. and I have just added this servo motor in the same circuit and connected this control signal to the servo motor and the power supplies. Just the same thing. I have same LED brightness control program only. I have used the same code and same circuit. Only add-on is this servo motor circuit. So if I change the position of this potentiometer, that value is being read through the analog sensor ADC, and that value is adjusted to 0 to 1023 from 0 to 255, and I am writing the same value, that converted value, to the pin number 9 to make this give the displacement angle value, or the I generate a PWM and I give it to the both LED and the servo motor. Just same thing. This program is just to demonstrate the working of this servo motor. Actually, just it is going to be controlled by the analog voltage, and that's all with this experiment. Thank you.